Hello again. So where we left off in the last video is we developed utility functions by labeling each of our indifference curves, where the lower the number associated with an indifference curve, the less happy we are with the choices on that indifference curve, right? So utility functions can tell us what's better and what's worse. But we were left stuck when it came to trying to figure out how much better something is. So for example, if we're back in our world of friends and TV time, right? And we wanted to know what's the value if you've got 5 hours with your friends and 5 hours on TV, and you want to know what's the value of a 6th hour of friend time. Knowing how much that 6th hour increases your utility doesn't help at all, right? And the reason it doesn't help is because we don't know from knowing how many utils you gain, how much happier you are, because utils are made up and arbitrary, right? We picked one utility function out of a potentially infinite number that we could have picked. So what can we do? If I want to know how much increasing number of hours with your friends from 5 to 6, how much that's worth to you, I have to compare your value of that 6th hour of friend time with something real, right? Utility isn't real. So what can I do? Well, the only other real thing in the story that we're drawing so far is time watching TV, right? So the logical way to think about how much do I value this shift, right? Or I'll say, actually, how much do I value this shift, right, from 5 to 6 hours of time with my friends, is to say, well, what was I willing to give up to get that 6th hour with my friends? How much TV time am I willing to lose in order to get that 6th hour with my friends? Now, how can we figure that out? Remember, what the indifference curve is doing is it's telling us everything better, everything worse, and everything as good as our original point, which I'll call point A. So how much TV time am I willing to give up to get a 6th hour with my friends? It's however much leaves me as happy as I was with 5 hours of friends and 5 hours of TV. In other words, the value of this shift, right, 1 hour of friend time is going to be the value of the shift in TV time that would put me back to the same indifference curve. So let's say this is happening. Right? So if point A and point B are on the same indifference curve, that tells me that I valued that extra hour of TV time as much as I valued that lost half hour, that extra hour of friend time as much as I valued that lost half hour of TV time. And so if I think about, what's friend time worth to me relative to TV time, I can just think about this ratio, right? Which is going to basically be the same as saying the slope, right? So 1 hour with friends is worth 1/2 hour TV when I start with 5 hours friends, 5 hours TV, right? So what I might want to say, I might want to take a ratio and say I'm willing to trade TV for friends at 1/2 to 1 ratio, right? I'm willing to give up half an hour of TV for every hour of friends. Okay, great. So we're on the right track here, right? This is a really good start. The only problem is my indifference curve is curvy. So the fact that I wanted to know how much an hour is worth changed my answer. If I wanted to know, how much is, let's say, 5 hours of friend time worth, I would have gotten a different answer, right? I would have gotten a different slope. And potentially, if I wanted to know how how much is 1 second of friend time worth, I would have gotten a different slope there too. So what we're going to want to do is we're going to want to think about how much is a marginal incremental increase in friend time worth in terms of a marginal incremental decrease in TV time. So we're going to define a marginal rate of substitution, right? If this is some sort of gross rate of substitution, rate of substitution, we're going to want to know the ratio at which you'll give up tiny amount of TV time for friend time. Right? So instead of thinking about what's 1 hour of TV time worth to me, I want to ask what's 1 second of TV time worth, or what's 1 millisecond of TV time worth, which you might be thinking about from your calculus class. What we're really asking for here is a tangency, right? When we're saying, if we take the amount of time, right, the amount of friend time that we're adding, and we make it smaller and smaller and smaller, eventually what we're going to get is we're going to get the slope of our indifference curve right at a particular point, right at the point where we've got 5 hours of friend time and 5 hours of free TV time. Cool. And if we do this, right, we can tell you how much friend time is worth relative to TV time in a marginal increment right at point A. Okay. So how do we do this? How do we figure out the ratio that you're willing to trade on the margin? Well, what we do is we just take what we did in this gross sense, right, when we want to talk about a whole hour, and we shrink it down to infinitesimal size. So the basic rule, right, is we need to have a change in friend time and TV time that leaves U of F and T constant, right? So we're going to say the change in U of F and T has to equal 0, right? What's the change in utility of F and T? It's going to be the partial derivative of U with respect to F times the change in F, right, plus partial derivative of U with respect to T times the change in T, right? I gain some friend time, that makes me happy. I lose some TV time, that makes me sad. How happy does gaining the friend time make me? It depends on how much utility I get for every extra unit of friend time. How sad does losing TV time make me? It depends on how much utility I get for every unit of TV time. And this has to equal 0. So we can rearrange this equation. We can say negative delta T is du dt has to equal delta F times du dF. So then we'll get negative delta T over delta F equals du dF over du dt. And this, right, the ratio of TV time given up for friend time gained is going to be our marginal rate of substitution, TF, for a particular amount of TV time and friend time. So how do we interpret this? Well, what this is telling us, right, is that I'm willing to give up more TV time, right? This ratio gets bigger, means I'm willing to give up more TV time when I value TV time less and when I value friend time more, right? If the marginal utility of friend time goes up, that means I increase the value I place on time with my friends, then the ratio goes down, right? I need to ask for less TV time. I need I'm willing to give up more TV time in order to get more friend time. If I value TV time more, if the partial utility of TV time goes up, then my ratio is going to go down, right? I'm going to value TV time more, so I'm going to be willing to give up less TV time for each unit of friend time. We said that the MRS is going to be the slope of our indifference curve, right? What this suggests is that when you've got a steep slope, like here, right? You're willing to give up more TV time for each unit of friend time than when you have a flat slope, like here, right? So if I call this C and this B, I know that the MRS at B is less than the MRS at C. Which means, right, that I value TV time less relative to friend time at point C than I do at point B. This is another way of seeing that diversity is better, right? As I increase my amount of TV time, decrease my amount of friend time, the relative value of TV time goes down. Okay, so where we've left things now, right, is we found out in theory how to calculate a marginal rate of substitution, and therefore how to tell ourselves how much we value TV time relative to friend time or friend time relative to TV time. But it's a little bit difficult to use this when we have preferences that just come from a person's heart, right? Comes from a person's mind. The curves that we've drawn so far are just my representation of how I feel about friends versus TV. How exactly are we supposed to take partial derivatives of a utility function that represents those preferences? So what we're going to do moving forward is we're going to come up with simpler mathematical expressions that get at some of the general characteristics we expect people's real preferences to have. So again, right, we're telling stories. We're not trying to perfectly reflect reality. We're trying to reflect reality just enough so that we get important points across. So maybe what I'm going to do, the equation that I'm going to use here, is I'm going to say that my utility function in terms of f and t is going to equal something like f to the 1/2 times t, right? Square root of f times t. Why am I going to choose this function? Because it's going to be easy to take derivatives. Now, first of all, what does this function look like, right? What do my indifference curves look like if I have this function? Well, we can think about this, right? We can understand this utility function by saying, let's pick a particular indifference curve and then find a couple points and see what the shape looks like. So let's take the indifference curve where u of f and t equals 12. Right? 12 is a nice number. It's got a lot of factors. So where are we going to have f to the 1/2 and t equal to 12? Times t equals 12? Well, we could have, say, f equals 1 and t equals 12. Right? That's definitely a point. This one here. We could have, let's say, f equals 4, right? So that f to the 1/2 equals 2. And then t would have to equal 6, right? There's another point there, right? Let's find another point. How about f equals 9? Right, so f to the 1/2 equals 3. And then t would have to equal 4. 5, 6, 7, 8, 9, and 4. Right? And of course, we could keep going, right? We could say, you know, f equals 16, t equals 3. And we'll stop there. 16 and 3. So we're going to get a shape out of this that looks more or less like the indifference curve that I drew before, right? It's going to bend towards the origin. If I pick any 2 points, the average is going to be better than any extremes. And as I have fewer and fewer and fewer hours with my friends, the amount of TV time it's going to take to compensate me for losing more hours with my friends is going to get higher and higher and higher, right? So this is basically what we're doing. So given that we've got this equation, why don't we try to calculate an MRS? So what we need to do to calculate the MRS, so we've got to say MRS TF for of T and F, sorry, F and T. We should put the F and T. Right? The way that I'm going to do this is by saying first I need du df, and then I need du dt. U of f of t equals f to the 1/2 times t. Okay, so I take the partial derivative of u with respect to f. What I'm going to do is I'm going to say, how does u change when f changes? Holding t constant, right? Treating t just like a number. So this is like f to the 1/2 times 4. Well, if I wanted to take the derivative of f to the 1/2 times 4, I would use the power rule, right? I would say, okay, well, it's got a coefficient of to the 1/2. So I'm going to take that down, right? So it's going to be 1/2 times f to the 1/2 minus 1, right? And then times 4, right? Times that constant, so times t. Right? And this is going to be 1/2 f to the negative 1/2 times t. Okay? So now I just need du dt. Right? This time we're going to treat f as a constant. Right? So this is 4 to the 1/2 times t, and I want to take the derivative. Same rule, right? This is just t to the 1. So this is just going to be f to the 1/2 times 1 times t to the 1 minus 1, right? It's just going to be f to the 1/2 times 1. So far, so good? So now my MRS is going to be, right, du df over du dt. Which is going to be 1/2 f negative 1/2 times t over f to the 1/2, right? F to the negative 1/2 is the same as 1 over f to the 1/2. So this is 1/2 t over f to the 1/2 times f to the 1/2. So this is just going to be 1/2 times t over f. This makes sense? So what do I know? I know that MRS, the amount of TV time I'm willing to give up for a unit of friend time, evaluated at a particular amount of friend time and TV time, equals 1/2 times t over f. So the more TV time I have, the more I'm willing to give up to get a little friend time. The more friend time I have, the less TV time I'm willing to give up to get a little more friend time, right? And if we think of the MRS as the slope of our indifference curve, which we should, we can see this here. The slope of the indifference curve is steeper when we've got lots of TV time. It's shallower when we've got lots of friend time. Okay, so a couple of final thoughts, final things to leave you here with the marginal rate of substitution. So the MRS for any two goods is the amount of vertical good you would give up for an increment of the horizontal good. It's also the slope of the indifference curve because if you give up the vertical good for the horizontal good, in that ratio, it keeps you indifferent, right? That's what it means to say that you're just barely willing to give up the vertical good for the horizontal good at that ratio. Last thing to remember is a function, the MRS is a function of the amount of the two goods. Right, so you don't want to think, I calculate the MRS, I get a number, that number is always true. Your MRS depends on how much you have of one good and how much you have of the other good. And if your preferences are well behaved, right, if more is better, it should be the case that the more the vertical good you have, the steeper the slope, the higher the MRS. The more of the horizontal good you have, the shallower the slope, the lower the MRS. And another way to think about this, the shallower the slope is at any particular moment, the more you value the horizontal good relative to the vertical good. Okay, that's it for today. Thank you so much for bearing with me, and I'm looking forward to talking to you more about this material.